Assalamualaikum and good day, team. Thank you all for joining this urgent meeting via Google Meet. As chemist officer under the Environmental Chemistry Department, we have been called to assess increasing reports of water quality degradation in the Mada region, Kedah, one of Malaysian main rice producing areas. Our early observation indicates signs of water pollution linked to improper pedophile management. Today's meeting will be focused on identifying the core issues and reviewing the evidence from our latest analytical tests and field visits. Let's begin with a report from our water quality analysis, Mrs. Putri.
Okay, thank you, Dr. Mai. I will be presenting the results from our recent monitoring of irrigation water quality across several sampling locations in the Mada region. The data were collected mainly from February to September and analyzed for key physicochemical parameters and pesticide residue. So I will presenting the result here. Wait. Okay. Let's see here. Okay, so one of the major red flags was the extremely high NH3 and value recorded in February 6.88. Wait, I'm so sorry. One of the major red flags was extremely high value recorded in February 6.88 milligram per liter, which exceeds the NWQS standard of 2.7 milligram per liter. This indicates a heavy load of nitrogen compound from fertilizer runoff even before the planting season. Nitrate values remain low overall, ranging from 0.00 to 0.11 milligram per liter, but this may reflect immediate uptake by algae or conversion processes. Ammonia, on the other hand, is more directly linked to recent urea or ammonium-based fertilizer use, especially without adequate absorption in the soil. So, Water Quality Index (WQI). The Water Quality Index varied significantly throughout the months. In March and May, the WQI dropped into Class 3, meaning the water was slightly polluted. In February and July, values were a bit higher, aligning with Class 2 standard. Soil manipulation and rainfall patterns seems to be key drivers. During planting preparation in March to May, increased disturbance causes more surface runoff, leading to higher pollutant level in irrigation channel. So, if we can see about the dissolved oxygen (DO) and total suspended solids, a worrying trend was the decline in dissolved oxygen (DO) from 6.62 milligram per liter in February down to 4.28 milligram per liter in May, which indicates potential eutrophication effects. Low DO harm aquatic life and in a classic symptom of nutrient overload. At the same time, TSS levels peaked in May at over 200 milligram per liter, almost double the 300 milligram per liter limit for irrigation water. High TSS can block sunlight and affect aquatic photosynthesis, worsening oxygen level and reducing water clarity. So for this, heavy metal accumulation. Another issue observed was elevated aluminium levels, especially in March and May, with a peak of 7.02 milligram per liter in March. This is well above the 1 milligram per liter standard for leaf crops and may impact crop growth. Fortunately, other toxic metals like lead, arsenic, and cadmium were either not detected or within safe limits during this sampling. Last but not least, pesticide residue screening. Our LCMS screening of irrigation water for pesticide residues revealed the most compounds were not detected in measurable concentration, which is encouraging. However, two exceptions were found. Thiametosem, a neonicotinoid insecticide, was detected, but below LOQ, which is limit of quantification. Imidacloprid was also detected at 2.14 microgram per liter, but again below quantifiable limits. These findings suggest potential pesticide infiltration, possibly from recent spray cycle, and require close monitoring. Okay. So, in summary, the data confirms that irrigation water quality is in Mada is under pressure from nutrient loading, particularly ammonium-based fertilizer, poor soil management, and potential pesticide runoff. Our concern is the shift in WQI and DO during critical growth month, which can cascade into environmental and agricultural consequences. So that is all from me.
So I will continue from that. I will present. Okay, so I will present about this. Building on that, I'd like to elaborate on the environmental chemistry behind the eutrophication process. Uh, what is the eutrophication? Eutrophication is the excess nutrients such as phosphate and nitrate from fertilizers and urea feed algae. So when this happens, there will be algal bloom that can block sunlight. When they block sunlight, they will disrupt the aquatic plant life. When this happens, the decomposition of algae use up oxygen that can cause hypoxia or dead zones. It also when the aquatic plant life disrupts, so there will no cycle of oxygen in the water. And then the impact, it will kill fishes and aquatic organisms, and then it can release toxins harmful to humans and animals. So how to you know so the observation we observe at the site, which is we can see the green scum seen on the water surface, which is the early sign of algal bloom. This is a serious environmental concern because it can disrupt our ecosystem and our environment also. Okay, so thank you.
Okay, next is my part, which is about the interview that I visit the farmer's body field. So thank you for Mr. Rahana. I recently conducted interviews site visit with several local farmers in the Mada area to understand their day-to-day agricultural practices. Unfortunately, I found two major issues that are contributing to the water pollution. First, Um, fertilizer are often applied without proper guidance on dosage or timing. Many farmers spray fertilizer just before it rains, believing this helps nutrients seep into the soil. However, this practice leads to surface runoff, where excess nitrate and phosphate are washed into the drainage system and nearby water bodies. Second, the drainage infrastructure in a certain part of Mada is outdated and poorly maintained. Some irrigation ditches are clogged with weeds and sediment, causing stagnant water that mixes with fertilizer and pesticides. This mixture then flows into rivers during heavy rainfall. While many farmers are aware of this problem, they lack technical knowledge, financial support, and real-time guidance. In fact, a few told me they would be open to adopting better practices if they were given a clear instruction, those on inactive. This highlights the need of for stronger collaboration between chemists, agricultural officers, and local communities to introduce sustainable and chemistry-based solutions. So, as a proof, I will provide the video that I interviewed the farmers. Assalamualaikum, Miss Sufi. Thank you for your speaking with us today. Can I ask, when do you usually apply fertilizer to your paddy field?
Oh, Waalaikumsalam, Miss Nasrin. Normally, just before it rains, the rain helps dissolve and separate it.
Oh, I see. Are you aware that this can cause chemical runoff into nearby rivers?
I heard about it, but we don't have much choice. The drainage is not good, and we follow old methods.
Oh, I see. Thank you for your information. I will use this information to the further improvement on this problem. Thank you for your time, Miss
Oh,
Sufi.
okay, welcome, Miss Nasrin.
Next, I will pass to the Mrs. Azhar.
Thank you, Mrs. Nasri from Agriculture License Chemist. So this issue doesn't just affect the environment, and it could also threaten our nation's food security. If this pollution continues, the contaminated water will be used to irrigate crops, and this could damage rice yield or introduce harmful substances into our food supply. Furthermore, Malaysia's water treatment facilities are not designed to filter high level of nitrate. This is very concerning because excessive nitrate in water can cause health issues like blue baby syndrome. So, immediate action is needed with collaboration between scientists, farmers, and policymakers. I suggest that in our next meeting, we discuss a long term strategy that includes regular chemical testing, education for farmers, and stricter enforcement of regulation.
Alright, thank you everyone. It's clear we're facing a multi-phase problem which is environmental, chemical, and social. In our next session, we will explore solutions based on analytical chemistry, water treatment technologies, and farmers' collaboration. Let's prepare our proposal for a sustainable science-based action plan. Meeting dismissed. Assalamualaikum and very good day to everyone. Thank you for being with us today. We are here to discuss a critical issue affecting paddy field in the Mada region, water pollution caused by excessive fertilizer use, pesticide runoff, and poor drainage. This problem impact not only the environment but also the health and income of our farmers. I'm Dr. Maisara and I'll be guiding you through our session today alongside our dedicated team of chemistry officers. First, we have Mrs. Putri who will present the water quality monitoring system. Then Mrs. Rehana will explain environmental solution to reduce runoff. Next, Dr. Nasrin will share strategy for effective farmer collaboration. And finally, Dr. Azza will cover the role of policy and support framework. So together, we develop a chemistry-based approach to help manage this challenge more sustainably. Let's begin with our first segment.
Okay, thank you, Dr. Mai. To address the water pollution issue in the Mada Peripheral, my role is to propose a water quality monitoring system that uses analytical chemistry tools. The goal is to detect nutrient buildup and pesticide contamination before they cause eutrophication or crop damage. Let me walk you through the monitoring plan. In paddy cultivation, fertilizer runoff doesn't happen randomly. It is closely linked to crop growth stage. Based on our field calendar, I have identified three optimal sampling periods. T1 corresponding to early vegetative phase when initial fertilizer are applied. T2 is during a panicle initiation and flowering when nutrient uptake is highest. T3 is near maturity when runoff from residual fertilizer is common. By aligning our water sampling to this stage, we can accurately track nutrient levels during the most critical periods of the paddy cycle. Okay. So, what we monitor and where? Okay. We will collect water samples monthly, 10 in from I mean Okay, I'm sorry. We will collect water samples monthly from 10 strategic locations within the Mada region, including primary irrigation channels and key drainage points. Each sample will be tested for nitrate, ammonic, ammoniacal nitrogen, phosphate, total suspended solid, pH, and dissolved oxygen. These are the core indicators of nutrient loading and water quality. Our goal is to identify hotspots of nutrient runoff and assess where intervention is most needed. Okay. We will also use UV-Vis spectrophotometry to detect pesticide residues. These methods allow us to identify specific agrochemicals by their absorbance peaks. For example, the spectrum here shows how compounds like MCPA and Mecocrop absorb strongly in the 220 and 280 nanometer range. By matching our irrigation sample to this spectra, we can determine if pesticide residues are entering the water supply, even at low concentration. To measure nutrient level precisely, we apply the Beer-Lambert law. This law states that absorbance is directly proportional to concentration, meaning that higher absorbance at a given wavelength equals more of that nutrient in the sample. For example, phosphate can be quantified by measuring absorbance at 880 nanometers. If we build a calibration curve, we can determine phosphate level in unknown samples based on their absorbance value. This gives us accurate quantitative data on pollution severity. Okay. So to centralize the data, we propose creating a digital dashboard. It will show nutrient trends across sampling location and automatically flag any values that exceed safe threshold. For example, if nitrate exceeds 10 mg per liter or if phosphate rise above zero point 0.1, the system will send an alert to the responsible officer and eventually even to farmers via a mobile notification. This helps us act before environmental damage occur. To test this system in the field, we recommend a 6-month pilot project in Pendang and Kubang Pasu. These districts were chosen based on our prior test result and high fertilizer usage. This timeline is as follows. In months 1 and 2, we will set up the monitoring station and trend field assistant. In month 3 and 4, data will be collected by analyzed. By month 4 and 6, by month 5 and 6, we will evaluate whether nutrient levels have decreased and determine farmer engagement. If nitrate levels drop below 10 milligram per liter and phosphate stays under zero point 0.1 milligram per liter, we will consider the pilot successful and propose expanding the system to the other mana zone. So the team that will involve is chemist officers, which is our group, a local mother representative, participating farmers and academic partners, UPM student and labs. Okay, so we will use the monitoring tools such as UV vis spectrophotometry, ion selective electrode ISE, mobile alert system via dashboard. So that is all from me. Okay, that is all from me. And I would like to invite Miss Raihana to continue with her presentation.
Thank you, Miss Putri, as your invite. So I will share my screen for my slide. Okay. So my field of study, I most of it in eutrophication. I mostly research about eutrophication, and I will present about how runoff from pesticides and fertilizers leads to algal bloom and its environmental impact of agriculture practices. So, what is runoff? Runoff is basically rain washes excess fertilizers and pesticide from farms, lawns, and such as golf courses. This chemical flows into river, lakes, and coastal water. So when they washes, the fertilizer contain nitrogen and phosphorus. These nutrients act like food for algae and can result nutrient pollution in water bodies because there are too many nutrients in the water bodies. So they eat more and then they reproduce more. So when excess nutrient, there will be rapid algae growth. It can form large mats or clouds that call algal bloom. It can be toxic or harmless, but all disrupt the balance of the ecosystem in the water body. And then when algae leave, they will eventually die and then sink in the water. So when they die, bacteria decompose them using oxygen, and they can cause hypoxia or low oxygen level, leads to dead zone. So basically, when they when they form algae bloom, they can disrupt the sunlight from the up to the aquatic plants in the bottom. So when there are no plants that can undergo photosynthesis, there will be no oxygen in the water. So it can add up to the things that had died there. When they die, they use oxygen too. So it can end up to a zone where there will be little to no oxygen level. So when this happens, fish and aquatic life die due to lack of oxygen. When they die, so many die, they can cause loss of biodiversity. So when too many things die there, they can affect drinking water, fisheries, and tourism. So pesticides don't cause bloom directly, but they can harm aquatic life, altering ecosystem. Because as we know, pesticide is like a poison for the plants. So it can eventually be our poison too. May support algae dominance by killing predators or competitors. So when pesticide in the water, they can kill the predators of the algae such as fishes and so on. So the summary is when the nutrient run off, it can lead to nutrient overload and can lead to algal bloom. Where algal bloom happen, oxygen depletion, and then it can cause ecosystem damage. So in conclusion, proper fertilizer and pesticide use are crucial, but we can preventing the runoff to help protect water quality and aquatic ecosystem. So the solution for this, we can make buffer zone or use organic practices instead of fertilizer and pesticide, and then we improve irrigation in the farm. So that's all from me.
Okay, next is my part. Miss Putri, can you help me to share my slide?
Oh, okay, sure. Wait for a sec.
Okay, thank you, Miss Putri. Okay, thank you for Miss Rehana for your presentation. And now I will share with you on how we can work closely with the farmers to manage chemical runoff and protect water quality using the both education and smart tools. Next. So the first one is the current challenges in the farming practice. Based on interview and the site visit in the Mada region, many local farmers are still using outdated methods. Most often depend on traditional knowledge or informal advice when apply fertilizer. One common one common practice is applying fertilizer just before rain, thinking it will help the nutrient deplete the soil. In reality, this causes runoff where excess nitrate and phosphate are washed into river and irrigation canal. There's also a lack of access to science reliable science-based information on correct dosage and timing. This knowledge gap is a major factor behind nutrient pollution. Next, next is about the educational workshop for farmers. To solve this, we propose a regular educational workshop in the farming communities. This session will teach farmers how to manage nutrient more efficiently, minimize pesticide use, and improve the irrigation system. The workshop will be backed by environmental chemistry data, helping farmers understand the actual impact of over-fertilization and runoff. This is not just about telling them what to do. It is about empowering them with scientific understanding so they can make better decisions in the field. Next. So this is the mobile app for the smart farming. To make knowledge more accessible, we also plan to introduce a mobile application for the paddy farmers. This app will help include the fertilizer dosage calculator based on crop size and soil condition, along with weather alert to prevent application before rainfall. With this tool, farmers can avoid chemical waste and reduce the chance of runoff. It merges modern agricultural chemistry with practical farmer-friendly tech. Next, so the next one is about the incentive and modern irrigation. We must address infrastructure and in motivation. We are proposed working with local council and agricultural agency to provide incentives such as small grants, subsidies or certification for farmers who adopt eco-friendly practices like using slow-release fertilizer or biopesticide. Additionally, traditional irrigation methods like open flooding need to be upgraded. This system causes water loss and nutrient leaching. We aim to promote controlled drainage systems that are more efficient and reduce chemical flow into rivers. Next. So, in conclusion, if we want real lasting impact, we must work with the people who are most connected to the land, who is farmers. By combining chemistry-based guidance, modern tools and community collaboration, we can help protect our waters and improve crop yield. Timing fertilizer is use is no longer just about maximizing harvest. It is about protecting ecosystem, human health, and the future of our food supply. That's all from me.
Okay. Thank you, Ms. Nafrin from Agriculture License Chemist. So now I want to present my slide. Can you guys see my slide?
Yes.
Okay. So good day everyone. I'm Dr. Ahza, the Policy and Regulation Chemist in our team. So today I will be presenting on the regulatory and policy framework for addressing water pollution in paddy fields area, with a focus on how we can support sustainable agricultural practices through science-backed policies. So, today I want to focus on impact of uncontrolled pollutions. Uncontrolled agriculture pollution poses serious threats to both the environment and public health. When excess nitrate and phosphate enter water bodies, they cause eutrophication and overgrowth of algae that depletes oxygen and harm aquatic life. In addition, high levels of nitrate in water can lead to serious health conditions such as methemoglobinemia, also known as blue baby syndrome. Unfortunately, our current water treatment systems are not designed to filter out high concentration of these nutrients. This is why clear and enforceable regulations are essential to prevent the situation from worsening. So next, I want to suggest that regulatory measures. So to address this, we propose several regulatory actions. First, regular chemical audits of agricultural zone should be conducted by the Department of Environment. Second, there should be strict limit on how much nitrate and phosphate can be discharged into water system. Third, we recommend a certification scheme for farmers who adopt sustainable paddy farming methods. And finally, the Environmental Quality Act 1974 should be amended to include specific nutrient discharge threshold which can be monitored through random testing. Next, combining policy practice and community. Regulation alone is not enough. Implementation must involve all key stakeholders. First, local councils can assist in monitoring and enforcing new guidelines. Second, NGOs and universities can play a crucial role in educating and training farmers. Third, the government should offer incentives to encourage farmers to follow eco-friendly practices. Most importantly, we must ensure farmers understand the regulations and feel supported during the transition process. So, in conclusion, our policies must be firm but also realistic with gradual implementation to allow adjustment. We must use scientific data to support and guide our enforcement efforts. Ultimately, our goal is to safeguard water sources, protect crops, and ensure the well being of our communities. A strong combination of chemistry, based solution, and policy enforcement is key to achieving long-term agricultural sustainability. That's all from my presentation.
Alright, thank you everyone. Now that we explore the technical, environmental, and social dimension of this project, let me walk you through how we will bring all these solutions together into a single, coherent action plan for sustainable paddy field management in Manda region. To begin, Ms. Putri has outlined a robust water quality monitoring system. We are targeting 10 key irrigation and drainage points in Padang and Kubang Basu, areas with known water quality challenge. So what is our goals? To reduce nitrate level to below 10 milligram per liter and phosphate to below 0.1 milligram per liter while ensuring no fish die off or algae blooms. This is supported by monthly monitoring using UV spectrophotometry, ion selective electron, and a real-time dashboard to alert users of pollution spike. Next, Mrs. Raihana addressed the environmental solution. She emphasized a simple yet effective practices like creating buffer zone, promoting organic fertilizer use, and improving irrigation method to prevent runoff. This will help reduce contamination at the source, especially near fertilizer entry points and stagnant drains. Then, Dr. Nasrin focused on the human element, our farmers. As she explained, lack of proper guidance often lead to chemical overuse. So, we will conduct training workshop, roll out mobile tools for smart fertilizer planning, and even offer eco practices incentive. Collaboration is the key here. We want farmers to feel empowered, not burdened. Meanwhile, Dr. Azhar led the policy foundation. By engaging with local council, NGOs, and university, we will push for stronger enforcement for sustainable practices while also advocating for government support and incentive. It's important that the right policies are in place to sustain this effort long term. Alright, so how do we bring all this together? Our final action plan includes in the first and second months, we will focus on setting up the water quality monitoring station at selected irrigation and drainage point in Pendang and Kubang Paso. During this phase, we will also distribute water testing kits and prepare educational material for farmers. In the third and fourth month, we will conduct farmers training workshop to introduce proper fertilizer usage, buffer zone practices, and smart farming methods. Simultaneously, we will pilot test and digital dashboard and mobile alert system to support real-time decision making on the ground. In the first and sixth month, we will collect and analyze data from the water quality test to evaluate improvement. We will also gather feedback from participating farmers and stakeholders to identify strengths and areas for improvement. So, based on the data reviews and stakeholder input, we will refine our strategy and prepare for expansion to other regions facing similar challenge within the mother areas. Throughout the 6 months, our team of chemists we will work closely with local mother representatives, academic partners, and farmers to ensure smooth implementation, timely problem solving, and transparent communication. So, in short, this project isn't just about solving pollution, it's about building a smarter, cleaner, and more sustainable farming system, together with the people who make it happen every day. Let's move forward with both science and community at the heart of what we do. Thank you, everyone.